All right, so before we start with a specific question, I want to talk to you about the empirical rule and what's called normal distribution. So most of these questions are about normal distribution, and basically what it says is that we have like this bell-shaped graph. I'm going to go ahead and change to a black pen to start with. So you have this bell-shaped curve, and if the mean of your data is right in the middle, and it kind of explains in Apex like the mean, median, mode is all the same. So if the mean is in the middle, then we're going to say 68% of the data falls within one standard deviation of the mean. So I'm going to kind of draw these lines right here. 68% of the data is within one standard deviation of the mean. So between that first like little notch to the right and notch to the left of the mean, in that section right there, so in that middle section, this represents 68% of the data, okay? Okay, so then if we go one standard deviation further than that, so another standard deviation and another standard deviation to the right and to the left, then this two standard deviations away from the mean would represent 95% of the data, okay? So if we now look, let's do like these dashed lines here. So if we now look from everything in between those two blue lines, so from the first blue line all the way to the second blue line, that is 95% of the data, okay? And then if we do one more standard deviation, so one more to the left and one more to the right, this would represent 99.7% of the data. Okay, so again, if I draw in these little purple lines to my curve, from the first purple line all the way over under your curve, all of that data to the next purple line is going to be 99.7% of the data, okay? So we're going to use that. I'm actually going to copy and paste this. We're going to use that concept for, honestly, most of these problems. Okay, so the first one here, it says, you know what, let me crop this a little bit. I don't need all that space, and I want to be able to write on top of that. Okay. So the first problem here, it says, suppose a normal distribution has a mean of 266 and a standard deviation of 12, okay? What is the probability that, so this is what we're looking for, the probability that x is greater than or equal to 278. Okay, so mean of 266, that number goes in the middle, so 266. And then a standard deviation of 12. That means if I go one notch to the right, like on my graph, if I go one notch to the right, I'm going to add 12. So 266 plus 12 is 278. Or one notch to the left, I'm going to subtract 12. So 266 minus 12, 254. Okay? Okay, so what I'm looking for in this problem, that's actually the number, 278. That's the number that I'm looking for. So I want to know what's the probability that that x is greater than or equal to 278. So everything, like all of the yellow stuff that I just highlighted, okay? So what we have to do for this one is actually a little bit difficult. We know that 68% of the data is that middle section, okay? So if I do 100 minus 68, it's going to give me all the rest. So think like 100% minus the 68% that's in the middle. So 100 minus 68 is 32%, okay? So all the rest of this, that means from here to here, all of that data plus all of this data is 32% together. So if I do 32% divided by 2, this is about 16%, and this is about 16%, okay? So to the left of my 68% and to the right of my 68%, if I split that in half, because I know I had 32% left over after I take out the 68% in the middle, if I split that in half, that means this yellow part, and then if I highlight this over here, this orange part, the yellow part is 16% and the orange part is 16%. So our answer here would be the probability of that little yellow section is 16%, okay? There you go. Okay, so the next one. A study has shown that the daily amount of milk produced by a dairy cow is normally distributed with a mean of 6.2 gallons and a standard deviation of 0.7 gallons on a given day. 99.7% of the cows will produce an amount of milk within which of the following ranges? All right, so let's just draw maybe a simpler curve this time. You know what? Here, I'll copy this part. So I want to just copy that part right there. Okay, so we're going to say our mean number in the middle, it said the mean was 6.2 gallons. So the mean is 6.2 in the middle. And then one standard deviation of 0.7. So 6.2 plus 0.7 to the right. And I want to fill in all of these is 6.9. If I add 0.7 again, I get 7.6. And if I add 0.7 again, I get 8.3. Okay. And then I'm going to also go to the left. So 6.2 minus 0.7 is my standard deviation. That's 5.5. I'm going to subtract 0.7 again, and I get 4.8. And then I'm going to subtract 0.7 again. I should get 4.1. Yep. Okay. And then it says 99.7. 99.7 is that purple section. So remember, like down here, we said these... all of the, like 99.7% of the data is between those purple numbers. So that would be for us 4.1 and 8.3, which is how we get our answer right here. 4.1 to 8.3 gallons, okay? All right, a juice machine is set to dispense 16 ounces of juice. The amount of juice dispensed is normally distributed with a mean of 16.15 and a standard deviation of 0.25. In which range will the amount of juice dispensed be found 99.7% of the time? This is just like that last one that we did. Okay, so the mean, again, it says a mean of 16.15. That goes in the middle, 16.15. Okay, and a standard deviation of 0.25. So if we do 16.15 plus 0.25, that gives me, I'm going to write it sideways kind of, that gives me right here 16.40. This would be 16.65, and this would be 16.90, okay? If I subtract, so subtract 0.25 from 16.15, this would be 15.90. Subtract 0.25 again, this would be 15.65. Subtract it again, this would be 15.40, okay? So again, within 99.7% is what we're looking for. That's these last two notches, the last two standard deviations. So that would be 15.40 to 16.90. And there's your answer. Okay. All right. Next one. Suppose a normal distribution has a mean of 98, a standard deviation of 6. What is the probability that x is greater than or equal to 92? So I'd like to paste that image again. Okay, so a mean of 98, we're putting that in the middle. A standard deviation of 6. So first I'm just going to fill out all of my, like all three of my standard deviations to the right and to the left. So if I add 6, 98 plus 6, that's 104. Add 6 again, that's 110. Add 6 again is 116. Okay, let's go the other direction. So let's subtract 6, we get 92. Subtract 6 again, you get 86. Subtract 6 again, you get 80. Okay, and then it says, what is the probability that x is greater than or equal to 92? So we're looking for, essentially, from 92 all the way to the right. Like, what percentage under the curve, under that little bell-shaped graph, does that cover? Okay, I know the middle part is 68, and then we said again, this middle part has to be 68, and then from this first all the way on, the rest of that we said is 16%. So 68 plus 16, 68% plus 16% is going to give you 84%. Okay, so that's where we come up with the answer for this one. All right. All right, next one. Suppose the heights of the members of a population follow a normal distribution. If the mean height of the population is 68 inches and the standard deviation is 4 inches, 95% of the population will have a height within which of the following ranges? Okay, so this is similar to what we did before. It's just using a different percentage now, 95 instead of 99.7. So it says the mean height of the population is 68 inches. That's what goes into the middle. The standard deviation is 4. So let's fill out our whole chart here. So 68 add 4 would be 72. Add 4 again, 76. Add 4 again, you get 80. Let's go the opposite direction. So we're going to subtract 4. So 68 subtract 4, you get 64. Subtract 4 again is 60. Subtract 4 again, we get 56. Now, from the very beginning, what we kind of explained was that 95% of the population is going to be between 2 standard deviations. So 2 standard deviations, here's the middle. I go 2 to the left is here, 2 to the right is here. So there's 2 standard deviations. So my endpoint here is 60. My endpoint here is 76. So between 60 and 76 inches, okay? All right. Next one. Suppose a normal distribution has a mean of 98 and a standard deviation of 6. What is the probability that x is less than or equal to 92? That is this problem right here. It's just asking something different. So I'm going to copy all of this that we already did. Copy. Let's paste it down here. Okay. So it says it has a mean of 98. That's what we have. And a standard deviation of 6. What is the probability this time that x is less than or equal to 92? So this time I'm looking at from 92 right here over here to the left. So what we said, again, if 68 is the percentage in the middle, then there's 16% of the curve to the right, and then this would be 16% of the curve to the left. So that's it. 16% of the curve is that orange section, okay? All right, one more. Which statement does not describe a normal distribution? So this is kind of the vocab from the beginning of section 10.2. The median is equal to the mean. That is actually correct. It talks about the mean, the median, and the mode are all the same for normal distribution, okay? The distribution is negatively skewed. We'll come back to that. So, well, actually, I'll just explain it here. So a normal distribution, like by definition, it has this bell-shaped graph. So negatively skewed means that it would be like longer on the left side, okay? So you would have kind of like over here, and then it would be like that. We don't have like such a long tail on the left side, so it would not be negatively skewed, okay? So that would be incorrect. So that's a no. I still want to check the rest to make sure. The number of observation trails off as you move away from the mean. That's correct. So right here in the middle, this is where most of the data is happening. It trails off as you go to the right, and it also trails off as you go to the left. So either side, it kind of really decreases as you go to the right and to the left. And then most of the observations are near the mean. That's why there's like this big hill in the middle. That's correct. So it's got to be this one. The distribution is negatively skewed.